Hello, welcome to the video. This lesson is section 2.4, where we're going to be looking at algebraic reasoning. So we're going to ask the essential question here is, how can algebraic properties help you solve equations? Not only that, this is another way that this is going to help you with um, getting introduced into formal proofs, being able to discover um, what you're supposed to do through a proof, kind of the steps into that. And one of the best ways to introduce it is by using it in algebraic form. So things that we have to do when we're looking at proofs is be able to support it with different properties. So uh, when you're using um, algebra and with these proofs, what we're going to do is we're going to use these properties of equality. So the properties of equality that we have in front of us are addition, subtraction, multiplication, division, and then we also have the substitution property. What this means is this. So in every single scenario, it says if A equals B, and then for like an addition, if you add something to both sides, it's still going to be the same result because you're adding the same value of C to both sides. It's a subtraction, you're subtracting C, multiplication, you're multiplying by C, division, you're dividing by C. The only thing that's different is substitution. Substitution says that if A equals B, and A can be substituted for B or B in for A in an equation. So, you know, this this then in some situations you're just replacing it, and then that's you're able to do that because of that property. A lot of times when we are writing proofs, it's being able to discover the reasoning behind the proof and why we were able to get to that point or get to that step. So with that being said, what we're going to do with this, it says solve 3x plus 2 equals 23 minus 4x, and then you're going to justify each step. What I would like you to do is start putting it into the column and the two column proof, because you're going to be writing that a ton as we move forward in the future. So let's just, keep it the same practice for this. So this would be like your statement, and over here would be like your reason for doing it. So to start with, the very first thing is you're just going to rewrite the problem. 3x plus 2 is equal to 23 minus 4x. And that is the problem, and the reason for that will just be given, because it was given to you. Now, the second thing is depending on what you want to do, I'm going to add 4x to both sides. So when I do that, this one's going to be 7x plus 2 is equal to 23. My reasoning, because I added, is going to be the addition property of equality. Next, I'm going to subtract 2 to both sides. So now I have 7x is equal to 21. And because I subtracted, the next reasoning is because I could use the subtraction property of equality. And then next thing, to get x by itself, I'm going to divide 7 to both sides, which then leaves me with x equals 3. 3 is the result, and the reasoning for that is because I could use the division property of equality. So you're just stating what you did to get to the next step. Okay, so with these examples here, I would encourage you to solve them yourselves. Again, if you are struggling with one, please leave a comment down below. More than happy to um, shed some light and give some clarity for that. Here is another uh, property that can be used, which is the distributive property. We've done it before. You have a value and it's being multiplied by a quantity of either a sum or a difference in this case. And if it's a sum, like it is here, it's going to be A times B plus A times C. If it's subtraction or difference, it's going to be A times B minus A times C. So again, we have this problem here. So I got my statement, I got my reason. First thing is just rewrite the problem. -5 times by the quantity of 7w plus 8 is equal to 30, and that is given. Second thing I'm going to do is I'm going to distribute that -5. So this turns into -35w minus 56 is equal to 30. My reason is the distributive property. From here, I'm going to add 56 to both sides, which then leaves me with -35w is equal to 30 plus 56, which is 86. And, oh shoot, it's not 56. I screwed up. This should be 40. So that means I'm going to add 40. Sorry about that. So this is 70, 30 plus 40 is 70. My apologies. Then from here, divide -35, which then gives me step 4, which will give me W equals 70 divided by -35, which is, looks like -2. Oh, and this one here, this reason is the addition probably because I added 40. And then the fourth one here is I divided, so it's going to be division property of equality. And you can abbreviate there, it's fine. Okay. Some other concepts that we're going to kind of look at, uh, whether it's pertaining to real numbers, segment lengths, or angle measure. They're all going to be the same property. They'll just have different looks to them. So the reflexive property is some value of A equals some value of A. AB equals AB. The measurement of angle A is equal to the measurement of angle A. So they're just going to be equal to themselves. Symmetric property is A equals B or B equals A. You just kind of flip them. Same thing goes for segment lengths and angle measures. The transitive property is if A equals B and A equals C, then the transitive property can say that A equals C because it shares that value from B. You could almost make an argument like you could substitute um, A into B into the second equation, and then that's how you can get A equals C, but they give you a different property for that. So in this example here, it says you reflect the beam of a spotlight off a mirror lying flat on a stage as shown. Determine whether the measurement of angle DBA is equal to the measurement of angle EBA. So anytime it has that M in front of it, they're talking about measurement. So from here, we can kind of write this out as like a two-column proof here. Now the things that you can take from a given perspective is what you see in the diagram. So if you notice, I have hash marks here and here with respects to the measurement of angle 1 and the measurements of angle 3. So I can say that measurement of angle 1 is equal to the measurement of angle 3. That is given. So basically what we're trying to do is figure out is dBA, which is right here. We want to know if that's equal to EBC, which is right here. So looking at this sort of one angle at a time, let's take a look at uh, dBA. So looking for step 2, you could use EBA if you wanted to. So the angle dBA is going to be equal to the measurement of angle 2 plus the measurement of angle 3. All right. Reasoning that we can take from this actually comes from chapter 1, and that's the angle addition postulate. Okay. And same reasoning for step 3, we can say that the angle EBC is going to be equal to the angle 1 plus the measurement of angle 2. And again, that's from angle addition. Now, what we can do from here is it all kind of depends on which angle you want to choose. I'm going to look at dBA just because I chose that one first. So the next step is going to be angle dBA. And in order for us to solve this, what I'm going to do is, if you notice, because one has 3 and one has 1, and we already established that 1 and 3 are going to equal to each other, I'm just going to substitute one of those in. So I'm going to say that angle 2 plus angle 1 uh, is an acceptable statement because I just substituted it in. I substituted 1 and 3. So the substitution property of equality allows me to do that. And angle 1 plus angle 2 is the same thing as angle 2 plus angle 1 here. So step 5 here, I could say that whatever the measurement of dBA is going to be equal to the measurement of EBC because of the transitive property. Because what you're saying here is dBA is this and EBC is also this. So you can kind of substitute that in here and this can kind of fit into there. And so, but that's where that transitive property comes into play. So that's how we can prove or determine that those angles are equal to each other through those reasonings of those properties and definitions. Here it's just asking you to name the property of equality that's illustrated. 7, looks like they're just flipped around, so it's symmetric. 8, they're the same thing, so it's reflexive. Here it's 1 and 2, 2 and 5, because these two meet. You can say that's 1 and 5, so that is transitive. And this is how we can use algebraic reasoning. Hope this helps. Until next time.